FMT cable stands for flexible metallic tubing. It is a type of electrical conduit specifically designed to protect wires and cables from physical damage. This protective layer is achieved through a flexible metal sheath, frequently manufactured using materials like aluminum or steel. The primary applications for FMT cable lie within commercial and industrial settings. These environments often demand a high degree of protection for electrical cables, safeguarding them against not only physical harm but also potential environmental hazards that might compromise their integrity. IGS cable, on the other hand, represents industrial-grade shielded cable. It is an electrical cable engineered for the demanding conditions of industrial environments. Its defining characteristic is a shielded outer jacket. This jacket serves as a barrier, effectively protecting the internal conductors from electromagnetic interference, also known as EMI, and radio frequency interference, often abbreviated as RFI. IGS cable finds its niche in applications where sensitive electronic equipment is in operation. Examples include manufacturing facilities where precision machinery is prevalent, hospitals with critical medical devices, and data centers housing sensitive information and requiring uninterrupted operation. In terms of commonality, FMT cable enjoys widespread availability and can typically be sourced from most electrical supply houses. IGS cable, however, is less ubiquitous. While not as readily available as FMT cable, IGS cable can be found at specialized electrical supply houses that cater to specific industrial needs. Both FMT and IGS cables are typically sold in coiled form or wound onto reels for ease of handling and distribution. If you are seeking samples of FMT and IGS cables, consider contacting the following companies. For FMT cable samples, you might reach out to Annixter, Graybar, or Cooper Industries. These companies are known distributors and manufacturers of electrical products, including FMT cable. To acquire IGS cable samples, consider contacting Belden, Alpha Wire, or Panduit. These companies specialize in the production and distribution of various types of electrical cables, including IGS cable. In addition to contacting these specific companies, you can explore online resources to broaden your search. Try using search terms like FMT cable sample or IGS cable sample. This approach can uncover companies that offer free or low-cost samples for evaluation purposes. When working with electrical cables and conduits, it is crucial to adhere to safety regulations and best practices. Always consult the National Electrical Code, known as NEC, and local electrical codes for proper installation and handling guidelines. Understanding cable specifications such as voltage and current ratings is essential for ensuring safe and reliable operation. Additionally, using appropriate connectors and fittings is crucial for maintaining the integrity of the electrical system. Consider the environmental factors in your specific application. Factors such as temperature, humidity, and exposure to chemicals can influence the selection of appropriate cable types and installation methods. In industrial environments, it is particularly important to protect cables from mechanical damage and exposure to harsh conditions. Proper cable management techniques, such as using cable trays and conduits, can help to prevent damage and ensure long-term reliability. When selecting cables, consider the specific requirements of your application, including the type of equipment being powered, the distance the cable needs to run, and the potential for interference. Using shielded cables, such as IGS cable, can help to reduce interference and improve signal quality. Always ensure that cables are properly grounded to prevent electrical hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. When working with electrical systems, always wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. This equipment helps to protect you from electrical shock and other hazards. If you are not familiar with electrical work, it is best to consult a qualified electrician. Electricians have the knowledge and experience to safely and effectively install and maintain electrical systems. Regularly inspect electrical cables and connections for signs of damage or wear. Damaged cables can pose a fire hazard or electrical shock hazard. Replace any damaged cables immediately. Keep electrical panels and equipment clean and free from dust and debris. Dust and debris can accumulate and cause equipment to overheat or malfunction. Follow manufacturer's instructions for installation, maintenance, and operation of electrical equipment. This ensures that the equipment is used safely and effectively. Be aware of potential electrical hazards such as exposed wires, frayed insulation, and overloaded circuits. Take steps to eliminate or mitigate these hazards. Never work on electrical equipment while it is energized. Always disconnect the power supply before performing any maintenance or repairs. Use a voltage tester to verify that the power is off before starting work. If you are unsure about any aspect of electrical work, consult a qualified electrician. It is always better to be safe than sorry. When running cables through walls or ceilings, use appropriate methods to protect the cables from damage. This may include using conduit, cable trays, or grommets. Avoid running cables near heat sources, such as furnaces or water heaters. Heat can damage the insulation and cause the cables to fail. Do not overload electrical circuits. Overloading a circuit can cause the circuit breaker to trip or the fuse to blow. If a circuit breaker trips frequently, it may be a sign that the circuit is overloaded. In that case, reduce the load on the circuit or have an electrician install a new circuit. Use extension cords only temporarily. Extension cords are not designed for permanent use. If you need to run power to a location that does not have an outlet, have an electrician install a new outlet. When using extension cords, make sure they are properly rated for the load they will be carrying. Also, make sure the extension cord is in good condition and does not have any frayed wires or damaged insulation. Unplug electrical appliances when they are not in use. This saves energy and reduces the risk of electrical shock. Keep electrical cords and cables away from water. Water is a conductor of electricity, and contact with water can cause electrical shock. Never use electrical appliances near water, such as in the bathtub or shower. If an electrical appliance falls into water, do not touch it. First, disconnect the power supply. Then, you can safely retrieve the appliance from the water. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical shock. Keep electrical outlets covered when they are not in use. This prevents children from inserting objects into the outlets. Regularly test ground fault circuit interrupters known as GFCIs. GFCIs are designed to protect against electrical shock. They should be tested monthly to ensure they are working properly. To test a GFCI, press the test button. The GFCI should trip and cut off the power supply. Then press the reset button to restore power. If the GFCI does not trip when the test button is pressed, it should be replaced. Be aware of the signs of electrical problems, such as flickering lights, sparking outlets, and burning smells. If you notice any of these signs, have an electrician inspect your electrical system. Early detection of electrical problems can prevent serious damage and injury. Remember that electrical safety is everyone's responsibility. By following these guidelines, you can help to prevent electrical accidents and ensure a safe environment for yourself and others. FMT cable, being flexible metallic tubing, is a versatile option for protecting electrical wires. Its flexibility allows it to be easily routed through tight spaces and around obstacles. The metallic construction provides excellent protection against physical damage, making it suitable for industrial environments where cables may be exposed to impact or abrasion. It's also resistant to moisture and chemicals, further enhancing its durability in harsh conditions. IGS cable, with its industrial-grade shielding, is specifically designed to minimize electromagnetic interference. This is particularly important in environments with sensitive electronic equipment where interference can disrupt signals and cause malfunctions. The shielding effectively blocks out electromagnetic radiation, ensuring the integrity of data and preventing equipment errors. It's commonly used in data centers, hospitals, and manufacturing plants where reliable performance is crucial. When selecting between the FMT and IGS cable, consider the specific application and the environment in which the cable will be used. If physical protection is the primary concern, FMT cable is a good choice. If electromagnetic interference is a major issue, IGS cable is the preferred option. In some cases, a combination of both types of protection may be necessary. For instance, in an industrial setting with both physical hazards and sensitive equipment, using FMT cable with an additional layer of shielding may be the best solution. Always consult with a qualified electrician to determine the most appropriate cable type for your specific needs. Proper installation is crucial for ensuring the effectiveness of both FMT and IGS cable. FMT cable should be securely fastened to prevent it from sagging or becoming damaged. IGS cable should be properly grounded to ensure the shielding is effective. Follow all applicable electrical codes and regulations when installing these cables. Regular inspection and maintenance are essential for maintaining the integrity of electrical systems. Check cables for signs of damage, such as cuts, abrasions, or corrosion. Replace any damaged cables immediately. Also, ensure that all connections are tight and secure. Loose connections can cause overheating and electrical problems. By taking these precautions, you can ensure the safe and reliable operation of your electrical systems. The National Electrical Code, provides comprehensive guidelines for electrical installations. It covers everything from wiring methods to grounding requirements to safety precautions. Adhering to the NEC is crucial for ensuring the safety of electrical systems and preventing electrical hazard. Some key NEC articles related to cable installations include Article 300, Wiring Methods, Article 310, Conductors for General Wiring, and Article 392, Cable Trays. These articles provide detailed information on the types of cables that are permitted for different applications, the ampacity of conductors, and the requirements for cable tray installations. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important to stay up to date on the latest NEC requirements to ensure your electrical installations are safe and compliant. In addition to the NEC, local electrical codes may also apply. Local codes may be more stringent than the NEC in some cases, so it is important to check with your local electrical inspector to determine the specific requirements for your area. Electrical safety is a critical aspect of any electrical installation. Always prioritize safety when working with electricity. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Disconnect the power supply before performing any maintenance or repairs. Use a voltage tester to verify that the power is off before starting work. If you are not familiar with electrical work, consult a qualified electrician.